Hello everyone, today we're going to analyze some SSL TLS traffic in Wireshark, and we're going to begin by adding a TLS filter so that we can only see that traffic. So as you can see here, we have the source of the very first packet is the client at 128.238.38.162, and the source from the second packet is the server at 216.75.194.220, and the sequence is client to server, client hello, server to client, server hello, server to client the certificate and hello done, client to server, client key exchange, change cipher spec, and encrypted handshake, server back to client with also a change cipher spec and an encrypted handshake message, and then the application data between the two. Now we're going to look at a client hello, and we can see that all of the SSL records contain this header, which is 5 bytes long and contains the content type, and in this case it is handshake 22, which is 1 byte, the version, which is 2 bytes, as you can see down here, and the length, which is also 2 bytes. Now back to the very first packet, we can see that this is the first client hello. Now this contains a challenge right here, and here's the hex that it contains. And it also advertises a set of cipher suites that it supports. And the very first one supports RSA for the public key algorithm, RC4 for the symmetric key algorithm, and a hash algorithm of MT5. And we can also see that the server has a chosen cipher suite that supports RSA, RC4, and MD5. Now, the server record also contains what is known as a nonce here, and we can see that it is 32 bytes long, which contains a 4 byte time and the random bytes that are 28 bytes long, and this is used to prevent replay attacks. Also contains a session ID, which allows the server to remember keys that are previously agreed upon. Now this record does not contain the certificate. The certificate is contained in the next packet, as we can see here. Now moving on to the client key exchange record, we can see that it contains the encrypted pre-master secret, which is used to create the master secret, which is used to create the session keys. We can see that there is also a change cipher spec, which is used for the client and the server, which also contains one to agree upon the protocol and the cipher used between the two. And then we can see that there is also encrypted handshakes that they use to verify that they are using the same protocols. And after that, we can see that there is encrypted application data sent between the two. In this application data, these packets also include a MAC here, which is not differentiated between the encrypted data and Wireshark. So thank you very much. I hope that you've learned something, and I learned a lot by doing this lab.